In this part of the lecture, we will talk about casting, and first we will discuss the casting of primitive types, for example, the integers and double. We have discussed casting previously in a little bit of detail. For example, we talked about widening conversions and wider assignment, wider casting, and then narrowing conversions. Wider casting means when we cast a value to a wider value, and it is always permitted in Java, but it is not explicitly required. For example, however, if we want to explicitly cast any value, then it makes our code more readable. Let's say we have a variable d that is of type double, and we have a variable I that is of type integer, and we have two more variables d1 and d2. Now in this case, double is considered as a wider value, and if we want to assign an integer value to a double variable, we can do that without any problem. We can do that without losing any information. We can do that without getting any compilation error. The reason for that is, as we can see, that a double value can store more detail, it can store more information than an integer value. That is why Java allows it without any explicit conversion. But if you want to explicitly convert the integer to a double, then we can use this syntax, where for example this is our integer variable int of type int, and this is the type that we want to convert it into, and we are assigning the converted int variable to the double variable. Both of these will work because this is a wider casting where we are assigning a smaller value to a larger value, so we are increasing the capacity of this narrow, let's say, data type to something that can store more detail. That is why it is allowed without any explicit conversion, like in this case. And if we do want to explicitly tell the compiler that we are converting, then for the sake of readability we can do this, but it is not required, as we can see over here. It is permitted without explicit conversion. So this can be called as assignment conversion. We are directly assigning the integer value to the double variable, and now the integer is the value of our integer variable is stored as a double value in our double variable. And this is casting conversion. In this case, this is optional because a double is bigger data type than an integer, and it can store more information than an integer data type can. That is why it is optional, but if for the sake of readability, if you do want to mention it, then we can do it like this. On the other hand, narrow in conversion, in which case we are trying to convert a bigger data type into a smaller data type. For example, a double data types can store more data, more details than an integer or int data type. And if we try to assign a double value to an int data type variable, we might get a compile time error. We might lose some information. For example, this is a double value, and if you try to assign it to an int data type, then as we understand that an int won't store anything that is beyond this point, then we will only get the value 4 and the 0.9, that is maybe an important detail. We might lose this information. And it can be seen with this example that we are trying to store more data in a smaller space. This bottle can hold more data or more material than this cup, and if we try to store larger data in a smaller value, then obviously, as we can see, that we can lose information. The reverse will be of this will be if we try to store the amount that the material of the cup in this bottle, that can the bottle can easily hold to that material. But if we try to store more material in a smaller space, then we might lose information. And we cannot do that by assignment. We cannot do this conversion by an assignment. You must use an explicit cast to convert a value in a large type to a smaller type, or else converting that value might result in a loss of precision. For example, as we talked about this example, D is a double data type and it stores 4.9. I, let's say, stores 10, I1 and I2 are int data types. If we try to do conversion by assignment, that will not be allowed by the compiler. We will get an error, maybe data type error or something like that. Assignment conversion compile time error will be produced. If we do need to convert this double value to the int data type, then we can do it explicitly by following the syntax of casting. And this is narrow casting. What would happen is we have stored this value D. The value of D was 4.9, but if we store it in an int data type variable, then we will lose anything that is beyond this decimal point. Everything beyond the decimal point will be truncated, and that is we need, that is where we need to be careful, that we might lose information if we are trying to convert from a larger type to a smaller type. We can see this chart, for example, which variables or which data types can lose information and which cannot lose information. If we are converting an int to a double, that is a wider type conversion and we do not need casting explicitly. And if we are converting a double to an int or anything beyond this point, then we do need casting. For example, a conversion of a character into an int will need casting. Conversion of a short to an int will not need casting, but the reverse will need casting. So whenever we are trying to convert a larger value to a smaller value, we will explicitly need casting, and we need to keep in mind that we might lose some detail whenever we convert from a larger value to a smaller value or smaller type. To talk about casting in objects, casting an object to a different type will permit access to fields shadowed by the type of the original object. Now we have used casting in objects in our previous lecture, where we converted an object of superclass to an object of subclass. And the reason for that conversion was, if we want to access an object, for example, if we want to access a method of the subclass, then we cannot do that with the object of the superclass. If we want to access a method in the subclass, then we have seen that in our previous examples as well, that we cannot do that with the object of the superclass. For that access, we will need to convert the object of the superclass into the object of the subclass, where that method has been declared and defined. Then we will be able to access that method with that object. So casting an object to a different type will permit access to fields shadowed by the type of the original object. So for example, if we are not able to access anything with the original object, then we may be able to access those fields by converting that object to a different type. Now we can only convert to objects of compatible types. We talked about compatibility when we were in the lecture of instance of operator. So the objects need to be compatible in order to be converted or casted. Otherwise we will get a compile time error. Casting an object to a different type will have no effect on which method it is invoked in response to a given message. Once overridden, methods remain overridden. Casting will only affect the type of the object. It will not affect the type of the method that is being called by that object. The object or the method will remain the same. It will not affect the overriding of the method even if it is being has been declared in the subclass. It has been overridden once and it remains overridden. To cast, just precede a value with the parenthesized name of the desired type. As we saw in our primitive type conversion, we can do the same, and with the objects as well. We need to write the name of the class that we want to convert the object to in parentheses, and then we will be able to convert that object. We'll see it in the example. A class cast exception is thrown if the type cast is incompatible with the type of object to be pointed to. As I said that we only can convert objects that are compatible with each other, and we have seen that what compatible objects can be. Those are objects which are related in an inheritance relationship, and we discussed in detail when we were talking about the instance of operator that what can are compatible or incompatible objects. So we can only convert between incompatible objects. If the objects are not compatible, then we will get this exception. Exceptions are the kind of errors that we get when we go into some problem. We will talk about exceptions in the next lecture in detail, although we have been using exceptions at a small scale in our code so far. To check that a potential cast is safe, the instance of operator should be used. And we use this in our instance of operator example in our lecture 16, that when we were trying to confirm if the objects are compatible with each other, we can check that through the instance of operator. It will check if an object is an instance of the other object, then possibly it can be converted, otherwise it will not be converted. The instance of operator can be used to determine the type of an object. It returns a boolean value. It returns true if object can be assigned into a reference of type, for example class name. That is, instance of checks if the object is an instance of the specified class, provided obj is not null. You can look into the instance of operator lecture if you want to go into the detail of this. It basically checks if an object is a reference type of a class, where when we were using polymorphism, for example we stored all the objects in an array of a superclass. Then if we were looking for an object of the subclass, we were able to do that with the help of the instance of operator. If it will check if the object is an object of the subclass, this class name will be the object of the will be the subclass that we want to compare it with. We want to check if the object belongs to this subclass, then it will be it may be converted or convertible. Otherwise, if it is not, then it will not be converted. And this is the syntax of the instance of operator that we have seen previously. Here we'll write the name of the object, the instance of keyword, and the name of the class. That will return a boolean value. We have some conversions, type of conversion, widening conversion and narrowing conversion with the objects, as well as we saw in our primitive data types. And wider object can be simply done through assignment conversion, or we can do it with reference casting as well. But as we can see that we have an object of the superclass, then we declare an object of the subclass. As we can see this hierarchy over here, this superclass is the wider type and the subclass is the narrower type. So it shouldn't be not a problem if we assign an object of the subclass to the object of the superclass, but the reverse will not be as simple. So as we can see that we have declared an object of the subclass and we can assign it to the object of the superclass because it is a wider conversion and we will not get any error for this. But as we understand that we cannot access the methods or any fields of the subclass inside through the object of the superclass. So we need to we have been talking about since our previous lectures that we are not able to access the fields of the subclass through the object of the superclass. We can do the conversion or casting using this syntax as well, but it will make no difference to the compiler. Widening casting conversion, it is okay, however no access to fields in derived. Reference conversion, like primitive conversion, takes place at compile time because the compiler has all the information it needs to determine whether the conversion is legal. As I said that it is checked at the compile time. If you remember from our discussion of compatibility between objects, you are getting a compile time error if you are trying to convert or assign incompatible objects to each other, and that will be done at the compile time. We will get an error if we try to convert an object to another object that are not compatible with each other, and the compatibility is usually determined through the inheritance relationship. Inheritance relationship is a relation. The parent object is more general than child object. That means that the parent object is the wider type and the conversion is straightforward. It can be done through simple assignment. The general rule of thumb is that converting to a superclass is permitted because superclass is wider type than subclass. But if we try to do narrow in conversion, direct assignment will result in compile time error. Narrow object reference assignment will result in compile time error, and we have seen this. Narrow object reference casting, on the other hand, it can be compile time okay, but at runtime, like primitive casting, by using a cast, you convince the compiler to let you do a conversion that otherwise might not be allowed. The runtime check determines whether the class of the object being cast is compatible with the new type. So if we try to convert through assignment directly, then we might get an error right at the compiling time, at the time of compilation. But if we use, for example, narrow object reference casting with that parenthesis using the syntax, then we might be able to go through the compiler, but then again it will be checked through the runtime that if the objects are compatible with each other or not. Again, if we look at our example, we have object of the superclass and we have object of the subclass, and then we have a few objects or variables of our subclass. Now in this case, the simple conversion or assignment is not allowed. We cannot assign an object of the superclass to an object of the subclass, as we have been saying that object of the subclass are object of the superclass, but the reverse is not true. We can do this by using this syntax. Now this will convert this object of the superclass to the object of the subclass. There are situations that we need to do this. There was a question in your mid exam. I'm not sure if most of you were able to get that, but you were asked to, for example, increase the price of the kitchen item, and what you were supposed to do was, for example, if you have an array of the superclass variables and those that array is storing the subclass objects, and if you want to access a specific object, subclass object, then you can use the instance of operator first to get the object, and then you can convert the object to an object of the subclass to be able to access a method that is specifically or exclusively defined in your subclass, because we cannot access our subclass methods through our objects of the superclasses. That is why in those situations we need to convert our objects of the superclasses into object of the subclass so that we can access our subclass fields. Now this will obviously give us a compile time error because we cannot assign an object of the superclass to an object of the subclass. We can do this by conversion using casting. Compile time OK, runtime error maybe B is an instance of class base not derived. So we might get this error if there is no relation between the classes. Now to avoid the compile time error, this is what we can do. We can declare the object of the subclass with the superclass reference, and that is what we do in our polymorphism as well. That is what we do in polymorphism, that we declare all our subclass objects with the superclass reference. Now in this case, if we try to use this conversion again, now this was okay at compile time, but at runtime this might get an error because these are completely separate objects. The subclass object is not initialized using the superclass reference as we have done over here. That is why we get a class cast exception. Now to avoid that error, what we can do is we can initialize our subclass objects through the superclass reference. Then we can convert those objects whenever we need to our subclass. Now the difference between this object and this object is that although these are our subclass objects, this one is with the superclass reference. Now the difference is that this object will not be able to access the fields in the derived method that are explicitly declared in the derived method. But this one, D3, will be able to access the methods of the derived class. And that is why we need to convert sometimes the object of the superclass into our subclass objects. Using casting. Why do we need to use casting? Using type casting, it is possible to recover a heading member. As I said that we may need to use casting if we need to access the methods or fields that have been overshadowed by our objects. For example, if we are using in this, as we have been doing in this case, we are declaring an object with the superclass reference, then we may not be able to access any method in this subclass, that is the derived class, but if and that is shadowed by this the type of the object that we are using. Because of that we cannot access the methods of this subclass. Now to avoid those situations we might need to use casting. Using type casting, it is possible to recover a hidden member, class variable, class method, or an instance variable, but not an overridden method, an instance method. An overridden method can be recovered only by means of a supercall and derived class. We have seen that previously, that how we can access the overridden method if we are using method overriding and we have the same methods and a superclass and a subclass, and if you want to access a method and of the superclass, then you can use the access that by using the super call, and the super call is by using the super keyword super dot and the name of the method. For example, we have these two classes, class base 2 with the variable integer x initialized to a value. Then we have a class that derives the base 2 class with the exact same variable. The name of the two variables is exactly the same, but the values are different. Now if you want to see which variable will be printed and which variable will be shadowed, we can use this example, and we can see that, for example, this object is initialized with the subclass reference, this object is initialized with the superclass reference, and in this case the value 10 will be shadowed when we use the subclass reference object, and the value of the subclass will be printed. But this is the value is hidden, and in the second case the value of, or if you want to access the value of the superclass, then we can convert it into the object of the superclass, and we can access the value of the superclass. So we can see that how values or methods can be hidden when we use inheritance or polymorphism, and if we try to access those values, then we can use casting for this purpose. There are certain rules that can be followed. For example, at compile time, checking is carried out to determine whether the cast type and the type of the existing reference variable are related through inheritance. So in classes we can only in objects we can only do casting among classes that are related through inheritance. At runtime, a check is made to determine whether the object actually pointed to is compatible with the cast type. And at runtime, it is made sure that if what we are converting is exactly compatible with the class that we are converting into. So, for example, we have this hierarchy as shown in this graph, and we have declared these objects. Student S1 is an object of this class, that is a subclass of the student class. Now S2 is an object of the tertiary student class. Employee, that is a subclass of the person class, but is in no direct relationship with any of these other classes. And then we have declared an object of the employee class. Then we have objects of these other classes as well. So if you want to see how are they compatible with each other, so now this object is compatible compile time compatibility, and this is runtime compatibility of the object, and these should work. If we try to convert this object into tertiary student object, this should first perfectly work. And same should be the case with this one, because it is already as of type tertiary student, then this conversion is already there. There is no compatibility between the tertiary student class and the employee class, so it should not be allowed by the compiler. It will not be allowed by the compiler if we try to convert the object of the employee class to an object of the tertiary student class. If we try to convert the object of, for example, S3 is an object of the college student class with the superclass reference. If we try to convert this, it should be okay at the compile time. If we try to convert this object to the tertiary student object, then it should be okay at compile time, but at runtime it will get us a compatibility. It will get us a compatibility error. S4 in this case, let's say S4 is an object of the superclass of the tertiary student, and if you try to convert the superclass object to the subclass object, then we might get this through the compiler, but at runtime we might not be able to get through with this. If we will get an error. And S2, that is a superclass of this tertiary student class, this should be okay. We can do it through direct assignment as well. An object of the subclass is already an object of the superclass, then they should work fine even without this explicit conversion. We can directly assign S2 to an object of the student class. So for the sake of compatibility, we need to understand these rules whenever we are trying to cast one object to another object. So to summarize, the things that we need to keep in mind: what object conversion does, make it possible to reference an object in a different way by assigning it to an object reference of a different type. So that is usually done when we are doing widening conversion, where we can automatically assign an object of one class into an object of another class. It is handled automatically by the compiler. So in this case, for example, if we are assigning an object of the subclass to an object of the superclass for some reason, then that should work fine without any error. The object is not converted or changed in any way. We need to keep in this in mind that even though when we assign an object of one class to an object of another class, the object in itself remains the same. It is not like our primitive data types. When we, for example, assign a value to a variable and then we replace it with another value, the value of the variable changes. That is not the case with the objects. Once instantiated, an object never changes its type. A cat will always be a cat. The concept is similar to the widening conversion performed on primitive data types. So when we convert to an wider value, the value of that variable remains the same. Now for casting, it is needed when the compiler doesn't recognize an automatic conversion. For example, when this assignment is not allowed or is not recognized by the compiler, then we need to explicitly do type casting. If you remember downcasting, we are converting an object of the superclass into an object of the subclass. That is the case over here. The concept is similar to the casting of primitive data types to perform a narrowing conversion. That is something that we do explicitly. Again, casting, like conversion, does not change the reference of the object being pointed to. It only changes the compiler's treatment of the reference. Casting is only legal between objects in the same inheritance hierarchy. We need to keep this in mind that we can only convert or cast between objects that are related through direct hierarchy or inheritance relationship. You can safely cast from an object of to its superclass. So casting does not change the reference, and we need to keep this in mind. It might be an important concept to remember that even though when we cast an object of one class to an object of the another class, that might allow the object to maybe access some additional data that are in the subclass, for example, but it does not change the value of the object. The object remains the same, but its referencing gets wider in this case and referencing gets narrower in this case. The value of the object never changes. You can go through this exercise and try to find out the solution for this, and you can write your solutions or your answers in the comments. This is another example. Maybe you can go through it, run it, and try to find the solution for it. Now to understand the difference between overriding, hiding, and overloading methods, an instance method in a subclass with the same signature, name plus the number of and the type of its parameters and return type as an instance method in the superclass overrides the superclass's methods. We have seen this that whenever we override a method, then there is a method in the superclass that is exactly with the same signature implemented in the subclass, and that is method overriding. If a subclass defines a class method with the same signature as a class method in the superclass, the method in the subclass hides the one in the superclass. By this we mean that when we, for example, declare an object of the subclass and we call the method, even though an object of the subclass is an object of the superclass, we will be getting the results for the method of the subclass. The method of the subclass hides the method of the superclass in this case, and that is what we saw with the variables as well. The variables of the subclass hide the variables of the superclass, and when we need to call the variables of the superclass explicitly, we need to use the super keyword. The distinction between hiding and overriding has important implication. The version of the overriding method that gets invoked is the one in the subclass. So when we use the call the method, the subclass method will be called. The version of the hidden method that gets invoked depends on whether it is invoked from the superclass or the subclass. So we can invoke the superclass method or the hidden method by using a call to the superclass method. Overloaded methods are differentiated by the number and the type of the arguments passed into the method. Overloading is, on the other hand, for example, if we change the number of parameters, then that is method overloading. The compiler does not consider return type when differentiating methods, so you cannot declare two methods in the same class with the same signature, even if they have different return type. The return type is not part of the signature of the method, so we cannot have a method with the same signature with different return types in a class. Then there are some example exercises. You can go through these exercises and try to find out a solution if there is any, or try to find out a problem if there is any. You can go through all of these exercises and try to find your solution and try to post your answer either in the Piazza page or in the comments on the KCMS. Go through these exercises one by one, and if there is any problem we can discuss those problems in our next lecture. This will conclude our lecture of static and dynamic binding and casting. We will continue our discussion of exceptions in our next lecture.